Up until now, with all of our force problems, we've been using geometry and trigonometry in order to figure out our components and our overall total. In this case, we're going to be using Newton's second law. It says a net external force of 150 newtons is applied to a 0.16 kilogram hockey puck. What is the acceleration of the puck? So we first can draw a diagram. Here's our hockey puck, and it's just hit and moving to one side. And so we have the net external force is 150 newtons. So that means sigma F is equal to 150 newtons. And it says a 0.16 kilogram hockey puck. So whenever something is in kilograms, that is talking about its mass. And we want to know what is the acceleration, so we're looking for A. Based on the information that we are given, we're going to use the second law of motion. So if we flip over here to our second law of motion equations, we see that we know sigma F and we know M, and we're asked to solve for A. So this is the equation we're going to use, that first equation. So now we can come back here, write down our equation as we see it on our equation sheet. Then we replace the numbers. We have sigma F to be 150 newtons, the mass to be 0.16 kilograms, and the acceleration is unknown. So to solve for the acceleration, we divide each side by the mass, 0.16. And we get our acceleration, comes out to be 937.5 meters per second squared. I know it seems like a very large number, but these numbers are accurate. A hockey puck actually is 0.16 kilograms, and 150 Newton force is not it's not a very large force in terms of the scale of newtons. An average person might be about 700 newtons, so it's not a very big number. It's very large. It's acted over upon a very small amount of time. The hockey stick is not in contact with the hockey puck for a very long amount of time, and so it does speed up rather rapidly. But watch for your units here. In order to be in meters per second squared, we must always be in newtons and kilograms. So when working through these problems, always make sure your units of newtons, kilograms, and meters and seconds, and then you'll be okay.